Hi guys, welcome to my YouTube channel. Today's lesson is going to be on the Big Bang Theory. So what better way than to start the topic by watching an episode of the Big Bang. So I'll catch you in about 20 minutes.
Our whole universe was in a hot, dense state that nearly 14 billion years ago expansion started. Wait, the earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall, we built the pyramids. Math, science, history, unraveling the mystery that all started with a Big Bang.
Gotcha! Did you actually think that we were going to watch an episode of the Big Bang Theory? Come on, you guys are funny. No, today's lesson really is about the Big Bang Theory, and we're going to talk about what it is and discuss the evidence that supports the current Big Bang Theory. So since it is a video, you can feel free to press pause, that way you have time to jot down a note. So enjoy, and I'll see you in class. There are some key terms that you should know before starting this lesson, the first of which is cosmology. Cosmology is the study of the origins and eventual fate of the universe. The universe consists of all of space, and that includes all matter and energy that's found everywhere. A galaxy is a clump of stars and planets that can be found in the universe. The solar system is one star and its surrounding planets. A star is matter that emits different amounts of energy, and a planet is matter that revolves around a star. The Big Bang Theory is the theory of how the universe came about 15 billion years ago. Before this time, there was nothing, not even atoms. The universe started as a single point which then expanded from that original state. The key thing to note is the Big Bang was not an explosion in the universe, but more of an explosion of the universe. And so the universe was created from that single point. The balloon analogy is something that we're going to expand further in class, but you can kind of think of the universe as a balloon that's being filled with air because the universe is constantly growing. And all of the white and orange dots that are on the balloon, those represent the galaxies and the matter that would exist within the universe. And so as the balloon continues to expand, everything moves further away from everything else, like all of the little dots. So that's kind of saying that if our universe is, getting bigger and bigger, then that means all of the planets, all of the stars are just naturally getting farther and farther away from each other as time goes on. This here is a really interesting explanation of the Big Bang Theory from when time begins to present day. It goes into much more detail than we need to know for our class, but I would recommend that you just pause the video right now and just have a quick read through all of the different steps there, because it gives you a greater understanding of the Big Bang Theory. The Big Crunch is another theory, and so the universe is constantly expanding, and cosmologists, they don't really know whether or not the universe will continue to expand or if it's going to eventually fall back into a single point. There are two key pieces of evidence that support the Big Bang Theory, and these are very good test questions. The first evidence is the cosmic background radiation. So that's just energy that's left over from the massive and quick expansion of the universe from a single point. The second piece of evidence is the red-shifted spectral lines of the galaxies. First up, we've got cosmic radiation. The early universe was extremely hot and filled with short-wave, high-frequency radiation, in other words, gamma rays. And then as it expanded, it cooled and radiation became low-frequency with longer wavelengths like X-rays, infrared, and microwave. The image below shows you the different types of radiation. You can kind of see how the gamma rays will have shorter waves and they occur more frequently compared to the microwave and the radio waves. This is a concept that you're going to go into much more detail when you are in grade 10. So if the Big Bang actually happened, the question is, where is the energy that should have been left over from the formation of the universe? And scientists predict that all of space should have forms of radiation present. The image there just kind of shows you the red and the orange and the yellow. Those would have higher concentrations of radiation than those of the blue and the turquoise. In 1965, there was a microwave antenna that was built that detected that the sky was filled with microwave energy. As technology advanced in 92, the COBE satellite then made detailed maps of the radiation. Then in 2006, The Wilkinson microwave anisotropy probe took even more precise measurements and created an even better map. And combined, both the COBE and the W map showed that the radiation fits the predictions that are consistent with that of the Big Bang Theory. The second piece of evidence is the red-shifted spectral lines. There is the idea that the universe is expanding, and so since it's expanding now, theoretically, it must have been smaller in the past. To understand, you need to know about light waves and the Doppler effect. Light is a form of energy that travels in waves. This kind of energy is called electromagnetic radiation. Each type of radiation has a different wavelength and frequency, as you can notice in the image below. Visible light is white light, and white light can be split into that light spectrum. You can do this by passing it through a prism, right? Just because that prism can cause that white light to bend, and it will result in that rainbow set of colors. All of the different colors, so red, orange, yellow, green, blue, indigo, violet, they have different wavelengths and frequency. The red has long wavelengths and low frequency, whereas things like the blue, indigo, violet, they tend to have shorter wavelengths and higher frequency. Right? You can kind of tell that it has shorter wavelengths because if you look at the arcs, they're closer together and you have more peaks and valleys than you do in comparison to the red. This here is the Doppler effect for a moving sound source. If you've got a police car heading towards you, you're going to hear the sirens very loudly because the wavelengths are shorter and they occur in high frequency. Whereas if the police car is driving away from you, the sound would be very faint because the sound waves would be longer in wavelength and occur less frequently. On that similar note, if stars, galaxies, things like that are moving away from you, you would see a red shift, whereas if they are moving towards you, you would see a blue shift. Every galaxy and star emits this special band of colors of light, and there are spectral lines that make each spectrum unique. Spectral shifting can occur at times. The first image there shows no shift, the second image shows a blue shift, and the third image shows a red shift. If a star is stationary and not moving, there would be no shift in the spectral lines. If a star is approaching you, then you would see a blue shift, and if the star is moving away, you would see a red shift. So blue shift would be short wavelength, high frequency. Red shift would be longer wavelengths, lower frequency. Astronomers noticed that in all of the galaxies being studied, the spectral lines were shifted towards the red end of the color band, and this means that stars and galaxies are moving away from us. And this supports the Big Bang Theory. Just to sum it all up, unshifted spectral lines means that objects are not moving away or coming towards and the universe is not changing in size. Red-shifted spectral lines means that galaxies are moving further away and that the universe is getting larger. Blue-shifted spectral lines means that objects are moving towards us and the universe is getting smaller. Red-shifted spectral lines supports the Big Bang Theory, whereas blue-shifted spectral lines supports the Big Crunch Theory. Big Bang Theory. So is it fact or is it fiction? Well, currently it is the most accepted explanation of how the universe was created. Scientists, what they've done is they've gathered all of the data and all of their results have pointed towards evidence supporting the Big Bang Theory. So until scientists can find evidence to disprove the Big Bang Theory, it will continue to be accepted as the explanation of how the universe was created. Science and religion. Now there are two different views. There are some people that believe that science and religion cannot mix. They're like oil and water. Whereas there are some people who can unify science, religion, and philosophy and kind of mix them all together and have come to the acceptance that they all can exist with each other.